Okay.
Hello, this is the safety team for experiment 9 for Gemma's Monday 4 p.m. lab session. And we're going to go over the risk assessment for experiment 9, which is on coordination compounds. So first, going over the safety table, we're going to go down in order. First is the hexaaqua cobalt 2 stock solution. Its formula is COH12O6. It has a health of 2, fire of 0, reactivity of 0, and it's an oxidizer that causes skin and eye irritation. Next is cobalt 2 nitrate hexahydrate. Its formula is CONO32, hydrated with 6 water. Its health is 2, fire 0, reactivity is 0, and it causes irritation. Next is potassium oxalate, C2K2O4, hydrated. Health is 2, fire 0, reactivity is 0, with no other hazards. Next is 3% hydrogen peroxide. Its formula is H2O2, health of 2, fire of 0, reactivity of 1, and it is an oxidizer. Next is trioxalate cobaltate 3 solution. It has a formula of C6COO12 with a health of 2, fire of 1, reactivity of 2, and it is also an oxidizer. Next is sodium glycinate with a formula of C2H4 and NaO2, health of 0, reactivity of 0, or fire of 0 and reactivity of 1, rather, and it has no special hazards. Next is triglycinate cobalt with a formula of CO C2H4NO2 with no health, fire, or reactivity special hazards, though it is an irritant. Next is sodium bicarbonate with the formula of NaHCO3. It has a health of 2, fire of 0, reactivity of 1 with no special hazards. After that is tricarbonate cobaltate 3 solution with a formula of COCO33-. It has a health of 2, fire of 1, and reactivity of 2, and it is an irritant. Next is a 3 molar nitric acid solution with the formula of HNO3. It has a health risk of 3, fire of 0, reactivity of 2, and it is an oxidizer. Next is hexaaqua cobalt 3 solution. It has a formula of CO with 6 water molecules. It has a health of 2, fire of 0, reactivity of 0, and it has no special hazards. After that is 1,10 phenanthrene with the formula of C12H8N2 with a water. It has a health of 2, fire of 0, reactivity of 0 with no special hazards. And last is tris 1,10 phenanthrene cobalt 3 solution, which is cobalt with the previously mentioned phenanthrene molecule. No health, fire, reactivity hazards, and no special hazards.
Okay. My name is Yava Medalinskaite, and I'm going to go over the chemical hazards, physical hazards, and hazards associated with equipment in this experiment. So the most dangerous hazard in this experiment is going to be handling cobalt 2 nitrate hexahydrate, and we should be wearing gloves because it can irritate the skin. We will be using some solid dusts as potassium oxalate, sodium glycinate, sodium bicarbonate, 1,10 phenanthrene, so be careful from inhaling them during the experiment. The concentrations of the solutions that we will be using in the experiment are low enough, so shouldn't be causing any irritation, but just be careful while handling them. Wear PPE during the lab and avoid contact with our materials. If any of the substances got spilled on the skin, wash immediately. If any of them got into eyes, rinse eyes with water and alert the TA. The physical hazards in this experiment involve the hot water bath that will be heated over an open flame. Do not leave the flame unattended and be careful around it. When handling the hot beaker, use appropriate equipment and try not to spill it. The hazards associated with the equipment involve when using the tricarbonate cobaltate, because while we're gonna be making the solution, it might bubble, so just be careful and remember to use flask for that. Um, and before using any other equipment, check for cracks in the glass.
Hi, I'm Isaac Talavera, and I'm going to be discussing any hazardous steps in the procedure and the precautions that should be taken, as well as how waste should be handled in the experiment and any other hazards that may come up. Particularly when mixing the liquid solutions, it's important not to allow anything to spill. This involves hexaquicobalt tricarbonate and hydrogen peroxide and the nitric acid. So to prevent spilling and splashing, it's important to use pipettes to safely add the liquid. Additionally, as mentioned previously, there will be solid dust in this experiment. So when pouring the dust into the solutions, it's also important not to allow the dust to spill or blow onto your skin or eyes, which again should be covered. Also, another note is when carrying the solid dust to create an indent in the weighing paper for the chemical to sit in when transporting and to move slowly. Again, to make sure none of the dust blows away. Additionally, when adding the hexaquicobalt to the solution, add it slowly into an Erlenmeyer flask to reduce any splashing because there will be vigorous bubbling. As a result of this, do not use test tubes when mixing the hexaquicobalt to the sodium bicarbonate solution. Always use an Erlenmeyer flask. For how waste should be handled in this experiment, all liquid waste should be disposed of in the liquid waste container located in the fume hood. The TA will indicate which container this is. For solid waste, you will use a solid or a separate solid waste container different than the liquid waste container. Again, this should be specified by the TA. Any non-chemical waste will be disposed of in the trash found in the lab as long as there's no chemicals on them. And there will be no chemicals washed down the drain, only water will be used in the sink. And there are no other special hazards or precautions for this lab to be noted.